So we were talking on features of TensorFlow. The third feature that comes to here is scalability. So TensorFlow is actually designed for scalability. It allows the users to train the model, to deploy the model on a variety of platforms. When I talk about scalability, how it is scalable, the model that it counts on. So, with TensorFlow, you can deploy this model on various hardware platforms which includes the CPUs, GPUs, and sometimes even distributed computing environments also. So thus it provides a good amount of scalability. That's why it is suitable for small scale as well as large scale machine learning or deep learning tasks. Now the fourth feature for TensorFlow is deployment. So it offers tools for deploying machine learning or deep learning models onto the various platforms, which even on mobile devices or on embedded systems, which are making it accessible for any real-time applications or edge computing applications. And then the next feature is community ecosystem. Okay, so community and ecosystem, TensorFlow, when I talk about TensorFlow, it has got a very large and an active community involving all the developers and the researchers, which helps to grow the TensorFlow, and it helps to contribute its growth actually. And it has got a rich ecosystem of libraries, tools and pre-trained models which can accelerate your applications based on AI and machine learning. These were some of the basic features of TensorFlow. Now coming on to the main part, which is the numeric precision. Now before I actually move into numeric precision, there are several components of TensorFlow that I want to tell about, is like TensorFlow serving. TensorFlow serving allows the models to be served as RESTful APIs. Similarly, you have got TensorBoard. TensorBoard is nothing but a visualization tools that is present in TensorFlow. These two are also some important features of TensorFlow. Now we are going to talk on much more deeper thing, which is numeric precision. So let's see this numeric precision characteristic in detail, which is very important feature of TensorFlow. So when in TensorFlow, it is similar to the other machine learning or deep learning libraries also. In TensorFlow also, numeric precision plays a very crucial role in determining the accuracy and the behavior of the model. The TensorFlow provides various options for specifying and controlling this numeric precision, which is particularly important when you are working with deep learning models or neural network models. Now, there are some important aspects of numeric precisions that you have in TensorFlow. So I have listed it down over there for you. I am going to elaborate it as I take one on them. So the first one that I am going to pick up, the important aspect of TensorFlow is data types. Okay, so TensorFlow supports various data types for representing numerical models, but the most common type of data type that you use to represent a real number is tf.float32 or tf.float64, or float32 precision or 32-bit precision or 64-bit precision. Okay, both of these are used. Now generally we go for 32-bit precision, but if you want to go for a higher precision, that is 64-bit precision, then it is going to consume more memory. So that's your call. Now second is mixed precision. In some of the deep learning applications, mixed precision is used to strike the balance between the speed and the precision. Okay, so it is something like mixed precision will use 16-bit floating point number for most of the computations, and for some of the critical parts of the model it is going to use 32-bit of floating point numbers, so that it can avoid loss of information. So wherever you have a critical area where you think that the information is very important at that time, you can go for a 32-bit precision and work for it, otherwise 16-bit well and good. So combining both of these will work inside a mixed precision. Now this particular approach can accelerate training while also preserving the accuracy of the model. So that is the second aspect of numeric precision. The third aspect of numeric precision here is quantization. Now this is a technique which is used to reduce the computational requirement as well as the memory of deep learning model. You all know that deep learning model you represent weights, and you also have activations, and all of these use lower precision integers in place of floating point numbers. So this is the quantization technique. So by using these lower precision integers, you are actually trying to reduce the memory used and the computations which are required for that particular model. Okay, so TensorFlow provide tools and libraries for quantizing models for various levels of precisions. It can even use 8-bit integers in quantization for quantization purpose. Okay. The next aspect that we are going for is a custom numeric precision. So the custom numeric precision allows you to define the custom type of data. You know, you can define your own custom data type and also your custom precision, numeric precision for specialized use cases. This is particularly useful when you are working with hardware accelerators such as GPUs and TPUs, where you know you will be working with different types of numeric precision formats. So you can make your custom made numeric precision using TensorFlow. Then the next aspect is numerical stability. So TensorFlow library consists of functions and various techniques which actually helps to enhance the stability in deep learning models, especially the numerical stability. So for example, certain specialized activation functions like ReLU, TANH, some weight initialization methods, and few of the places where you are using vanishing gradients and exploding gradients, will see them as and then, but all of these things could actually affect the model training. So your TensorFlow actually includes functions and techniques to enhance numerical stability in these deep learning models which use specialized activation functions, weight initialization methods, or whenever you are going for vanishing gradient or exploding gradient, all these things need stability and TensorFlow provides that. And then the last aspect that we are going to see in under numeric precision is hardware consideration. So hardware consideration means you have got choice of hardware like CPU, GPU, TPU, and definitely it is going to impact the numeric precisions available for computation. If I want to give you an example, then TPUs and GPUs actually support hardware accelerated operations in lower precision format like float 16 format. So, you know, with the choice of the hardware, your numeric precision also changes. So, you can consider working with the different types of hardware irrespective of taking tension for your numeric precision, whether. So this is what, you know, numeric precision is actually providing you with a good amount of compatibility to work on various platforms, to work on various hardwares, to work on various types of GPUs, TPUs. Without thinking a bit about numeric precision, you can build a model and provide stability. You can reduce the storage by using quantization, and definitely you can work on various platforms by using mixed precision. So all these aspects which are important in numeric precision of TensorFlow makes it worthwhile to use it as a deep learning framework for our models. So this was about introduction to TensorFlow.